In today's lesson, we will be finding the rate of change or slope in many different scenarios, and this is all an introduction into the linear function. To solve for the rate of change, there are 4 different scenarios that I'm going to write out that we use depending on the situation we have. And here I've drawn just a small coordinate plane with the x and the y axis, and then a linear line that goes through the plane and has these 2 points on it. So, to find the rate of change or the slope, the first thing is you are going to find the change in your y values and divide by the change in your x values. That little triangle just means change. Another way to write this is you can think about this. The y values represents the vertical axis. So you could think of it as vertical change over horizontal change. And then we often refer to this as rise over run. Rise meaning vertical change, and then run meaning horizontal change. And then there's one more. I want you to think about independent versus dependent variables. Which one corresponds to your x and which one corresponds to your y? Because in a real life scenario, our y values represent a dependent variable. So it's the change in your dependent variable divided by the change in your independent variable. All 4 of these are basically saying the exact same thing, which goes back to change in y divided by change in x. I just often will say different things depending on the scenario. So here we have a graph that is comparing distance in miles over time in seconds, and we want to find the rate of change. So if you think change in y divided by your change in x, where you have the x-axis and the y-axis, you have to be careful on this because when you initially look at it, it looks like the rise over run is up 1 over 1, up 1 over 1, up 1 over 1. So you'd think 1 divided by 1 is 1. However, that's not the case because you need to look at the intervals. Our y values are changing by 2 each time, going up by 2. So my rise is 2 over my x, they're changing by 10 each time. So my run, my change in my x values, is 10. And 2 over 10 reduces to 1/5. So my rate of change in this case is 1/5. In our second example, we have a scenario in a sentence here. A baby is 18 inches long at birth and 27 inches long at 10 months. Find the rate of change. So in this scenario, I want to think about dependent and independent variables. So remember, we want to find the change in the dependent variable and divide it by the change in the independent variable. Our 2 variables, we have inches going from 18 inches to 27 inches, and then we have time in months. And at birth would be 0 months to 10 months. So in this case, the growth in inches depends on how much time has passed. So we want to look at the change in inches divided by the change in months. So 27 minus 18 gives us the change in inches, and then 10 minus 0, the change in months, which is 9 over 10. And that is fully simplified, so the rate of change is 9/10. Now we are going to consider some linear lines and find the slope. And when we're dealing with a linear equation, we often refer to the slope as m. And this comes from the equation that we're going to learn in a couple lessons of slope-intercept form, where we use m to represent slope. And to do that, same thing, change in y divided by change in x. But in these graphs, we often just look at rise over run, because the unit of change, our intervals, are going by 1, so it's easy to just look at rise over run. So you want to find your x and your y axis, and then we need to find 2 points and then find the slope between those 2 points. Here it's given to us at the point 2, 1 and this point 5, 6. So to find the rise over run, always start with the left point, and we want to figure out how much do you rise to get to your next point and how much do you run. In this case, we went over or up 1, 2, 3, 4, 5. So my rise is 5 and my run is 1, 2, 3. And then that cannot be reduced at all. So that's my final answer. M equals 5/3. That's my slope. Let's do the same idea in this next example. Looking for just the x and the y axis here. And as you can tell from left to right, this line is decreasing. So that means my slope is going to be negative. And then these 2 points are given to us. And we want to find rise over run. Always start with the left point here, and then how much do we rise? Well, we're actually going down 2, and then we run over 3. So because I had to go down 2, my rise is -2, and my run is 3, so my slope is -2/3. I want to look at these 2 lines at the same time because in these two, students often mix them up. Let's first look at this horizontal line and think about the slope. Find 2 points, any 2 points, and think about rise over run to go from this point to this point, the left point to the right point. The rise, you don't have to go up any. So the rise is 0, and the run is over 1, 2, 3. And 0 divided by 3 is 0. If you look at the second one, pick 2 points, any 2 points, and think about rise over run. So the rise, you could think of it as up 1, 2, 3, and then the run is 0. However, you can't divide by 0, so in this case, the slope is undefined. Another thing that I like to think about that helps me remember the difference between these is imagine yourself walking these 2 lines. On this left one, if you're walking this line, you're not increasing or decreasing, you're not going uphill or downhill, so therefore your slope is simply 0. But if you try to walk this line, it is a cliff, and you're going to fall down this cliff and die. Therefore, the slope is undefined. Now we're going to learn the formula to find the slope between 2 points. So here I've listed 2 points. Every point has an x and a y. And on the left one, it's just x1, y1 to represent the first point, and then x2, y2 to represent the second point. So to find the slope between 2 points, still going back to thinking about change in y divided by change in x. So to find the change in y, we just subtract. So the slope between 2 points, this formula, the change in y would be y2 minus y1 over the change in x, which is x2 minus x1. And you actually will get the same thing if you reverse this. Y1 minus y2 divided by x1 minus x2. You just have to be careful. It does not equal the same thing if you do y2 minus y1 divided by x1 minus x2. So notice how this last one is different than the first two. You want to make sure y2 and x2 match up, y1 and x1 match up. You never want them to be opposite like this. So to find the slope between these 2 points, we need to find the change in our y values, y2 minus y1, which would be -4 minus 5. And then we're dividing by x2 minus x1, which would be dividing by 3 minus -2. So, in the numerator, -4 minus 5 is -9. And then in the denominator, 3 minus -2 would be 3 plus 2, which is 5. So -9/5 is fully reduced, so that is my slope between those 2 points. -9/5. Okay, same thing for the second example. M equals change in y, y2 minus y1, so 9 minus -2, divided by x2 minus x1, 4 minus 4. In the numerator, 9 minus -2 would be 9 plus 2, and then 4 minus 4 is 0, but we can't divide by 0, so in this case our slope is undefined. And this makes sense because if you graph, let's see, go over 4, down 2, and then over 4 up 9, that would create a vertical line which has an undefined slope. Here are 2 more examples I want you to try on your own, so go ahead and pause the video and try them and then come back and check your answer. You should get -2 for the slope between the first 2 points, and you can always check this on a graph. If you graph these 2 points, over 8 down 4, and then over 5 up 2, if you were to connect those 2 dots, there should be a slope using rise over run of -2 in between those 2 lines, or those 2 dots. And now for the second example. In this example, you should get that the slope is 0. And if you plot those 2 points, this should make sense because, let's see, the point 7, 9, and then the point over 2 up 9, if you connect those 2 dots, it's just a horizontal line which has slope 0. So there's your full lesson on finding the rate of change or the slope on graphs in real life scenarios and between 2 points. Good luck with the lesson.